In this lesson, we are going to learn how to find zeros using the quadratic formula. The first part of your notes here, target 5A, is about completing the square to create a quadratic formula. This is a lot of math that's going on this part of the notes. A couple things I want to point out here. Notice we start out in general form. We learned about this in target 1A. Ax squared plus bx plus c is general form. Now, since we're finding zeros, we're going to set that equation equal to 0. And then using a method called completing the square, which is pretty much the rest of this, both of these columns here, we go from this general form to quadratic formula. This is quadratic formula right here. It's really important that you work on memorizing this because you're going to need it for junior year, the SAT, things like that. All the math that goes on in between this step and this step is just kind of an FYI. We want to show you and make sure that you realize that this formula doesn't just appear out of thin air, but at the same time, we don't want to overwhelm you with the details of it. So now that we've gone through that, let's go ahead and get started solving. So target 5B is really where we're going to focus our efforts on this or during this lesson. It's using the quadratic formula to find zeros. Notice the quadratic formula is rewritten on this page here, so you don't have to keep flipping back and forth. And that's kind of really nice and a great thing to do when you're doing your homework. At the top of each page, write down the quadratic formula. That way you don't have to keep flipping back and forth. The first thing we need to do when solving with the quadratic formula is we need to identify A, B, and C. We should be pros at this by now from all the graphing work that we had done earlier, but remember A is always your first value. In this case 3, B is the second value, -5, and C is 2. Remember A is in front of the x squared, B is in front of the x, and C is your constant. From here I like to set up this shell here. Every place that I see a letter in the quadratic formula, I replace it with a set of parentheses. That reminds me that every time that I replace a value or substitute, it needs to happen in parentheses. That will prevent so many mistakes, and I cannot stress that enough. Again, every time you do substitution in the quadratic formula, you must do it inside of parentheses. From here now, we're going to literally go to the formula and use our list of letters here, our A, B, and C, and we are going to replace the letters as appropriate. So opposite of B here, -5, plus or minus the square root of B squared, -5 squared, minus 4AC, or 4 times 3 times 2, all over 2 times 3. This part can be the most challenging, and it's the part that I encourage you to check before continuing on until you get really comfortable with it, because if you can't do the substitution step correctly, the rest of your problems won't be correct. Once you've done the substitution step, I like to work on the outside of the square root first, or the radical symbol. The double negative here makes a +5, and 2 times 3 gives us 6. Next, I want to figure out what goes under the radical, so I'm going to use my calculator and I'm going to type this in exactly the way it appears without the square root symbol. So with parentheses, -5 squared minus 4 times 3 times 2 gives us 1. 1 is a perfect square, so we're going to go ahead and evaluate that. Ironically enough, the square root of 1 is 1. Now, this is really the first time in math that we've seen this plus or minus symbol. Us mathematicians are efficient and don't like to write things more often than we have to. But what this simply means here is that you have 5 plus 1 over 6 and 5 minus 1 over 6. Since everything is the same other than the plus and the minus, we condense it and write it all at once. 5 plus 1 all over 6 gives us 1. 5 minus 1 all over 6 gives us 2. So our solutions, or our zeros, to this quadratic equation are x equals 1 and 2/3. Okay, on to the next problem here. Like I said, every time I start a problem, I start out by listing what A, B, and C are. From there, then, I'm going to substitute. And when I substitute, I should get this. Notice every time I substitute in here, I do it inside parentheses. Negative B plus or minus the square root of B squared minus 4AC all over 2A. Next, I work on the outside. So the double negative makes a positive 5. 2 times 1 is 2. And then I type this all into my calculator without that square root symbol. When I do that, I get 81. Once again, 81 is a perfect square. The square root of 81 is 9. Now, remember, the plus or minus is two separate operations. So 5 plus 9 over 2 gives us 7. And 5 minus 9 over 2 gives us negative 2. As a reminder, zeros come from the x-intercept, so almost all of our problems should have two solutions. Every once in a while, we'll see a problem with 0 or with one solution, but you should almost always have two solutions here. Problem number 2 is a great problem to do on your own if you feel that you are ready. It is the second problem in the lesson, so I am going to walk through it verbally, but if you want to pause the video and try this or come back and try it later, you can. But this is probably the one problem if you wanted to try one on your own with some and then get some feedback on it. This would be the problem to do it on. But I'm going to go ahead and walk through it. First thing we need to do is we need to list out our A, B, and C. Next, we need to substitute, again, the parentheses. I know I sound like a broken record, but I cannot stress how important those parentheses are. Once you've substituted, deal with the outside, the negative 3 and the 4, and then we're going to deal with what's underneath the radical. So the 3 squared minus 4 times 2 times negative 20 gives us 169. Once again, we get a perfect square with that 169. The square root of 169 is 13. Negative 3 plus 13 all over 4 is 5 halves. And negative 3 minus 13 all over 4 is negative 4. Notice I wrote my answer as a fraction, not as a decimal. Decimals are never allowed when using the quadratic formula. So if you get a decimal, you either need to bring it back to a fraction like you do here, or you need to bring it back down to a simplified radical, which we'll see later on. Hopefully you're starting to get the hang of this. We have 2 more problems to deal with, 2 different types of problems to deal with. Make sure though that you feel comfortable with problems 1 and 2 before continuing on with the video. So problems 3 and 4 here. Again, problem 3, we're going to start. List out the A, B, and C values. Then we substitute. Hopefully by now you're starting to feel a little more comfortable with the substitution step. Once we've substituted, we need to deal with the outside, negative 4. 2 times 9 gives us 18. And then we need to deal with underneath the radical. This time, 592 is not a perfect square. You end up with a decimal, and decimals are not allowed. So we need to go back, and we need to go back to our unit 5 skills of simplifying radicals. And in order to do that, we need to make a factor tree. I'm going to do that over here in green. What times what gives us 592? I figured out that 16 times 37 is 592. 16 is a composite number, so I can keep breaking it down. And when I break it down, 16 is 8 times 2. The 8 breaks down to 4 times 2, and then the 4 breaks down to 2 times 2. Once we get all of our primes, we're going to want to write them underneath the radical symbol. And then because we're talking square roots, we're looking at groups of 2. 2 of the same number. And I have 2 groups of 2, which gives me 4. And then that 37 is stuck on the inside of the radical. So it is left underneath the radical. So the square root of 592 simplifies down to be 4 rad 37. Once I've done that, I can go back to the original problem over here in blue, and I can replace this square root of 592 with 4 square root of 37. Now, unlike the previous problems, I can't actually get rational answers here. The only thing that I can do is I can actually reduce this. The square root symbol protects the 37. So I'm just looking at the negative 4, the 4, and the 18. What number goes into all 3 of those? The answer to that is 2. So I need to divide each one of these numbers, the negative 4, the 4, and the 18 by 2. To get negative 2 plus or minus 2 rad 37 all over 9. Again, the 37 is protected, and I look to see what goes into the negative 4, the positive 4, and the 18. That's how I reduce my answers. This can be one of the more tricky parts, so don't be afraid to reach out should you need help on this. If you had stopped here, you still would have gotten most of your points, but it's really important that you get as many points as possible so that so it's important that you know how to fully reduce. So one last problem type, and that's problem number 4 here. Just like all of our other problems, we're going to start out by listing our a, b, and c value. Then we're going to substitute into the parenthesis or into the formula itself, remembering we always substitute inside parentheses. When we simplify our radical, we end up with -6 plus or minus the square root of -44 all over 8. Now I want you to take out your calculator and I want you to type in the square root of -44. What does your calculator tell you when you type in the square root of -44? You should get some sort of error. Most of the calculators say no real answer. And that's because you cannot take the square root of a negative number. You will learn more about how to deal with that when you get to AAT. But if you are ever solving a quadratic equation using the quadratic formula and you end up with this negative under the square root, we simply write no real solution. There is a solution. It happens to be an imaginary solution, and you will learn about that when you get to AAT. So it's not okay to say no solution. You have to have that word real in there, no real solution. So hopefully these 4 problems have gotten you comfortable with the quadratic formula. Do not hesitate to let Mrs. Newman or I know if you have any questions or need further assistance, but you should be ready for your homework. Thanks for watching.